Hello, everyone. I wanted to do a few more examples of finding reference angles. This can be kind of a confusing topic, and we didn't have enough time in class to do a lot of these. So I wanted you to have um, some more examples. All right, so let's work through number one here. So we want to draw this in standard position and calculate the reference angle. So before we can calculate the reference angle, we have to figure out where this angle has a terminal side, because the quadrant where the terminal side lands is going to determine kind of how we can find the reference angle using our formulas that we did in class. Or as we graph it, then we'll kind of get a feel for where the reference angle is and how big it is. Excuse me. Okay, so if I want to figure out where 3 pi over 5 is, this is a positively rotating angle. It's going to start here along the positive x-axis in standard position and rotate up clockwise, and we just have to figure out where the terminal side is going to land. So as we rotate positively, up here at the top would be pi over 2 radians. Over here on the left would be pi radians. Down at the bottom would be a positive 3 pi over 2 radians. And over here would be 2 pi radians. Now, in order to compare these and figure out where this lives, I need to create a common denominator between all of these fractions. The common denominator that I can put all of these up to would be, yep, 10. And so I'm going to have to multiply each of these fractions by a form of 1 to make it a fraction over 10. And we'll figure out what each of these equivalences are over 10. All right, so 3 pi over 5, I'm going to multiply that by 2 over 2 to get that denominator to be a 10. And when I multiply across, I get 6 pi on top. So this is 6 pi over 10. Pi over 2, I'm going to have to multiply that bottom by a 5 to get to 10. So I have to multiply the top by 5. And when I multiply across, I get 5 pi over 10. And then over here, pi over 1, I'm going to have to multiply by 10 on the top and the bottom. So when I multiply across, this is 10 pi over 10. And I'm going to have to multiply this guy by 5 over 5. So that's 15 pi over 10. And 2 pi, I would multiply top and bottom by 10. So that would be 20 pi over 10. Okay, so now that I have everything in terms of the same denominator, now I can figure out where this angle lands. So I'm trying to graph 3 pi over 5, which is the same as 6 pi over 10. So I'm going to start here in standard position, and I'm going to rotate up here to the vertical. That's going to be 510 over, sorry, 5 pi over 10, but I have to go to 6 pi's. So I'm going to have to go up here and keep rotating. So I'm going to be between 5 and 10 pi. I'm going to be here in the second quadrant, and I just have to go 1/5 of the way here to 10 pi over 10, right? I'm at 5 pi over 10. I just need to go 1 pi over 10 here. So it's going to be here somewhere. Again, that doesn't have to be perfect. We are kind of eyeballing this, and that's, I don't know, about 1/5 of the way between 5 pi and 10 pi over 10. So that's my 6 pi over 10. This is my angle theta. And now that's graphed in standard position, but now we need to find our reference angle. The reference angle is the acute angle between your terminal side and the x-axis. So the smallest angle here between my terminal side and the x-axis is this guy right here. That's my reference angle. I'm going to call that theta sub ref. That's my reference angle, and we have to find out how big it is. Now, reference angles are always positive. It's just the amount of space it takes up. These guys don't rotate in standard position, so they're not going to be positive and negative. It's just the amount of space between the terminal side and the x-axis. So my terminal side is at 6 pi over 10. The x-axis is at 10 pi over 10. So that means that this reference angle takes up You got it, 4 pi over 10 radians. That's the amount of space here between 6 pi over 10 and 10 pi over 10. And we can reduce that. 4 pi over 10. Let's see. I can't. Okay, so if I simplify that, I can take a 2 out of top and bottom. That is 2 pi over 5. That is my reference angle in simplified form. And in quadrant 2, if you wanted to use the formulas that we came up with in class, in quadrant 2, your reference angle, your theta ref, is found by 180 degrees. In our case, it's pi radians minus your theta. So we could do pi minus our theta, which was 3 pi over 5. We could get a common denominator to subtract those. I'd have to multiply by pi. I'd have to multiply pi over 1 by 5 over 5. That would be 5 pi over 5 minus 3 pi over 5. You would still get 2 pi over 5 using our equations that we came up with in class. But I find that if you are drawing it in standard position, it makes it much easier to kind of logic out the size of your reference angle. And that usually makes your life a little bit easier. So common denominators aren't as difficult. Okay, so that is number 1. We did number 2 in class. So I'm going to go all the way here to number 3. Let's graph 45 degrees in standard position and find its reference angle. Okay, this is a positively rotating angle. So again, I'm going to start at the positive x-axis. That's my initial side. And it's a positive angle, so I'm going to start rotating up. And I'm going to go counterclockwise. And I just have to figure out how far to go. So again, my landmark points here, this time in degrees, this is 90 degrees up here. That's 180 degrees. 270 degrees would be down here, and this would be a full 360 degrees. So to get to 45 degrees, I'm going to go halfway up to 90. So I'm going to go up here and stop. And at the halfway mark, that's going to be my terminal side. So this is my 45-degree angle. That's my theta. And we are graphed in standard position. Now I have to figure out what my reference angle is. Your reference angle is the acute angle between your terminal side and the x-axis, which here is right here. That's your theta ref. That's the same angle that we just rotated through with theta. And again, in the first quadrant, your theta ref and your theta angle will be the same. So here my reference angle is 45 degrees. It's the same as my original angle. That's always going to happen when your terminal side lands in quadrant 1. If you only went, if you are a positively rotating angle between 0 and 360 degrees. They'll be the same. Okay, cool. Well, that wasn't so bad. Let's keep going, because the more we do these, the easier it will get, and we'll start to get the process down, and it'll start to sort of make sense and sink in. Okay, so let's do number 4. We have 5 pi over 4. We need to graph this in standard position first. So again, this is a positively rotating angle. So we are going to start by putting our initial side on the positive x-axis and rotate up counterclockwise. Now we need to figure out how far we go. So let's put our landmark points in here. And now we just have to figure out how to compare these guys. Common denominators. What would the common denominator be between 5 pi over 4 and all of our landmark angles here? Yep, we would have to make a denominator of 4. So this already has a denominator of 4, so I'm good. And I'm going to have to multiply each of these by a number to get to a denominator of 4. Okay. And so if I come up here to pi over 2, I need to multiply the bottom by 2 to get to 4, so I'll multiply top and bottom. And when I go across, that's 2 pi over 4. At pi over 1, I'm going to have to multiply the bottom by 4 to get to my common denominator, so I'll do top and bottom by 4. When I multiply across, I get 4 pi. 3 pi over 2, I need to do top and bottom by 2. So when I multiply across, I get 6 pi. And 2 pi, I need to multiply top and bottom by 4 to get that common denominator. And when I multiply across, I get 8 pi. Okay, so now that we have common denominators, we can start to compare these things so that I can graph this correctly and figure out where 5 pi over 4 stops. So we're going to start at our initial side here on the positive x-axis and rotate up. We're going to rotate all the way up to here. That's 2 pi over 4s, but I need to go to 5 pi over 4s. So I'm going to keep going. I get here, and that's 4 pi over 4s, but I have to keep going. If I went all the way down here, I would be at 6 pi over 4s. That's too many. I have to go halfway between 4 pi over 4 and 6 pi over 4. So this is going to end halfway between those. That is where my 5 pi over 4 lands. Okay, so 5 pi over 4 is down here in quadrant 3. That's what this angle looks like in standard position. Now we have to figure out what its reference angle is. Where is my reference angle, the smallest angle between my terminal side and the x-axis? Yep, it's this guy here between my terminal side and the x-axis. We're above that terminal side. That's my reference angle, theta ref. And we have to figure out how much space is between there. And since we've already graphed it, 5 pi, that my theta ref is the space between 4 pi over 4 up here and 5 pi over 4 down here. The amount of space between 4 pi over 4 and 5 pi over 4 is 1 pi over 4. That is my reference angle. Or if you wanted to use our formulas from class, 5 pi over 4 is a positively rotating angle in one trip around the circle. So I can use my formulas that we talked about in class. In quadrant 3, my formula said that theta ref should be my angle theta minus pi. And so to figure out what my reference angle is, I would take my theta value, that's my original angle here, 5 pi over 4, and I'm going to subtract pi. Again, you would need a common denominator to subtract those. So I would do 5 pi over 4 minus 4 pi over 4. And we would get 1 pi over 4 as our reference angle there using our formulas if we decided to do that. So you can really go either way. I'm showing you both ways. That doesn't mean that you have to do it both ways on every problem. I'm showing you both ways because some of you are more visual and logicking it out from here will make sense in your brain. And some of you are less visual and that you're going to have a harder time with that than with these formulas. So you only have to do one of those, and I want you to do the one that makes more sense in your brain. All right, let's just keep rocking and keep doing these. So number 5, 11 pi over 6. We have another one in radians. So I'm going to make my circle here. Sorry, I'm going to try to keep it a little smaller so I can keep everything in here. And I have a positively rotating angle in radians. So again, I'm going to start at my initial side on the positive x-axis and rotate up counterclockwise. And we have to figure out how far we're going to go. So I'm going to have to put all of my landmark points in here. And I have to get a common denominator so I can compare these. What would our common denominator be here? Yep, it's going to be 6. So this already has my original has a denominator of 6 already. So I just have to multiply each of my landmark points here by something to get a common denominator of 6. And so let's see, I'm going to multiply by 3 over 3 here, and so that's 3 pi. I'm going to multiply by 6 over 6 here, so that's 6 pi. 3 and 3 will give me 9 pi over 6, and I'm going to have to do 6 over 6. That's 12 pi over 6. Okay, so hopefully you are okay with that. Because I'm going to have to do another problem over here, I'm just going to condense this down. So 2 pi is 12 pi over 6. I'm just going to kind of erase this and put 12 pi over 6 there. Hopefully you're okay with that. Sorry if there's any confusion there. I'm just want to make sure I have space for the next problem too. Okay, so now that we have all of our landmark points with the right denominator, now I can figure out where this thing is going to end. So I start here and I rotate up positively. When I get here, I've rotated through 3 pi's over 6. But I need to go through 11 pi's, so we're going to keep going. When I get here, I've gone through 6 pi's, got to keep going. I get down here, I've gone through 9 pi's, I have to keep going. But if I go all the way around up to here, I'm at 12 pi's, which is too far. So I can't go all the way there. So I'm just going to go between 9 pi and 12 pi. I need to go 2/3 of the way through here. So pretend this is a circle and I'm going 2/3 of the way through there. And I'm going to say, there we go. That's about 2/3 of the way through this quadrant. This is my 11 pi over 6 terminal side. And I rotated through all of this counterclockwise. Okay, so this angle lands in quadrant 4. Now that we have it graphed, let's figure out where my reference angle is. Where is the smallest angle between your terminal side and the x-axis? Yep, it's right here. That's my theta ref. So I have to figure out how much space is between my terminal side and the x-axis. My terminal side ends here at 11 pi over 6, and the x-axis, the closest part, is here at 12 pi over 6. So how much space is between 11 pi over 6 and 12 pi over 6? Yep, it's 1 pi over 6. That is my reference angle. And again, if your brain doesn't like the visual there, if you want to use our formulas from class, this is a positively rotating angle in one rotation of the circle. So in quadrant 4, our equations said that theta ref was going to be 2 pi minus my angle. And here it's going to be 2 pi minus my theta of 11 pi over 6. You'll get a common denominator, and that's going to be 12 pi over 6 minus 11 pi over 6, and you will get 1 pi over 6 as your reference angle. Again, you can use either the kind of the formula here, or you can just logic it out from the circle and say, oh, I've already graphed this. I can see that my reference angle is the space between there, and that's 1 pi over 6. I'm totally fine with that. Okay, so now we've done one in every quadrant here. Now let's turn it up a little bit and see what happens when we get some weirdos. So let's look at number 6 here. Number 6 is a little weird because it's negative. All of our angles so far have been positive. And again, we can use the formulas from class with positively rotating angles in standard position. But this is a negatively rotating angle, so we're going to have to be a little more careful with that. Okay, first thing that we have to do is graph this in standard position. So I'm going to graph it in standard position. I know my initial side is going to be here on the positive x-axis, but because I have a negative angle, instead of starting here and rotating up, I'm going to rotate down clockwise. And then we have to figure out how far we're going to go. As I go around, remember everything goes upside down when we are rotating negatively. So negative pi over 2 comes down here. Negative pi is over here. Negative 3 pi over 2 is up here. And negative 2 pi is over here. Yep, everything's upside down when we are going negative. So be careful with that. But now we are just going to do the same thing that we did before. And to figure out where everything goes, we need common denominators. Our common denominators is going to be 6, right? And we just found common denominators with 6. So I'm just going to grab our equivalencies from here. Hopefully you're okay with that. This was our 3 pi over 2. So it's actually going to be this one. We're upside down again. This is going to be negative pi over 6. Pi was over here, so that's going to be negative 6 pi over 6. Pi over 2 was actually up here. We're upside down, so this is going to be negative 3 pi over 6. And 2 pi was still here, and this is going to be negative 12 pi over 6. Okay, so now we have our common denominators, and we can go. So we're going to start at our initial side on the positive x-axis and go clockwise to here, negative 3. I got to go to negative 19, so I'm going to keep going. Negative 6. I have to keep going. Negative 9. I have to keep going. Negative 12. I still have to keep going. I'm not there yet, so I'm going to go all the way around the circle and keep going. Now, I have to figure out where my equivalencies are going to go. So let's kind of work our way around the circle. This was negative 3 pi over 6, 6 pi over 6, 9 pi over 6, 12 pi over 6. If I keep going around, this is going to be negative 15 pi over 6, right? I'm adding 3 every time. So it was 3, 6, 9, 12, 15 pi over 6. This is going to be negative 18 pi over 6. If I keep going, this will be negative 21 pi over 6. And if I keep going, this is going to be negative 24 pi over 6. I can use the pattern to keep going. Okay, so now that I have my next round of common denominators, let's see where we go. So I was at 12 here. I'm going to keep going to here is 15, but I have to go to 19, so I'm going to keep going. This is negative 18. I have to keep going. If I go all the way up to here, I'm at negative 21, but that's too far. I only had to go to 19. So between negative 18 and negative 21, I just have to go a third of the way up here. I would say that's about a third of the way up. It's not perfect, but I'm eyeballing it. It's about a third of the way up, right? This is where negative 19 pi over 6 is going to land. So this is my angle. I went all the way around the circle and then over halfway around again. This is my angle in standard position. Whew. Okay, so now that we are graphed in standard position, let's find our reference angle. Again, my terminal side is right here. So what's the smallest angle between my terminal side and the x-axis here? Yep, it's going to be this angle right here. That is my reference angle. Now, how big is that? Well, it's the space between this guy, negative 19 pi over 6, and this guy, which was negative 18 pi over 6, right? That was the last thing that we saw, the last coterminal angle that we saw there as we continued through. So the space between negative 18 pi over 6 and negative 19 pi over 6, yep, that space is 1 pi over 6. And again, our reference angles are always positive. I don't really care whether we were rotating positively or negatively. Your reference angle is just an amount of space. So it's always going to be positive. Okay, now, what if your brain is not um, graphic and it's not very visual, and you think, Susan, I need to know how to do this with my formulas from class? Well, those I kind tried to warn you, those formulas were only good for positively rotating angles in standard position. So what we're going to have to do here is find a coterminal angle to negative 19 pi over 6 that is in one rotation of the circle. So basically what we're going to do is we're going to find the first positive coterminal angle. How do we find coterminal angles? Yep, you add one trip around the circle. We can add 360 degrees. Here we will be adding 2 pi. So to find a coterminal angle, I'm going to take negative 19 pi over 6, and I'm going to add 2 pi. Now we're going to have to get a common denominator to add those. So I'm going to get negative 19 pi over 6 plus 12 pi over 6, because I'm going to multiply this by 6 over 6. Becomes 12 pi over 6. So now when I add these, negative 19 pi plus 12 pi, that's negative 7 pi over 6. That's still negative. I need it to be positive. So now what do we do? Yep, we add 2 pi again. So we're going to take negative 7 pi over 6 and add 2 pi. And so we're going to do negative 7 pi over 6, and we're going to add 12 pi over 6. And negative 7 pi plus 12 pi gives me 5 pi over 6. This is my first positive coterminal angle. This is what I'm going to use for theta in my formulas. So we are in quadrant 2. And in quadrant 2, our formulas say that our reference angle is pi minus theta. And here we're going to use the positively rotating coterminal angle. And so I'm going to do pi minus 5 pi over 6. Again, you need a common denominator, so pi becomes 6 pi over 6 minus that 5 pi over 6. Sorry, try to get that all in here. And we subtract 5 pi from 6 pi, and we get 1 pi over 6. This is my reference angle. Notice it's exactly the same thing that we got here. You can do one or the other, whichever your brain works. But if you want to use those formulas from class, if you have a negatively rotating angle, or if you have an angle that's positively rotating but goes around the circle more than once, you're going to have to bring it down to the first coterminal angle that would have been positive. And then use that for your theta in those formulas. Hopefully that all makes sense. I want to do a couple more of these because, again, I know that this is kind of getting longer than I wanted, but reference angles are something that can be really confusing. If your brain is very visual, I want you to graph it in standard position and then logic out that reference angle. If you need that formula, find your first positive coterminal angle. Okay, so now let's do this one, negative 320 degrees. Okay, negative 320 degrees. This is a negatively rotating angle, so I'm going to start at my positive x-axis and rotate down clockwise. And I'm in degrees, so down here, and it's negative, right? So I'm going to be upside down. So down here is negative 90 degrees. This is negative 180 degrees over here. This is negative 270 degrees, and this is negative 360 degrees. And so now we can kind of keep going and figure out where we go. So negative 90. I got to keep going because I got to go to negative 320. Here's negative 180. Got to keep going. Negative 270. I got to keep going. Ooh, negative 360 would be too much. So I'm going to go most of the way, let's say slightly over halfway between 270 and 360. Okay. Right, because halfway would be what, 300, My brain doesn't want to do that right now. 315. So we're slightly past halfway. Okay, so our terminal side is here, a little over halfway. This, and I got to put my arrow on here so that I know which way we rotated. And so this is my negative 320 degree angle in standard position. So where's my reference angle? It's the space between my terminal side and my x-axis. Sorry. Try it again. It's right here. And that's my reference angle. How big is it? This is going to be the space between negative 320 and negative 360 degrees. The amount of space between there is, yep, it's 40 degrees. If you wanted to use your formulas from class, you would have to first turn this into a positively rotating angle in one time around the circle between 0 and 360. So to find your coterminal angle, you would take negative 320 degrees and add 360 degrees. When you do that, you would get 40 degrees. 40 degrees is your first positively rotating angle. That's the one that we are going to use for theta. And we are our terminal side is in quadrant 1, so our formulas say that your theta ref, your reference angle, is equal to your angle theta, which here is 40 degrees. So that says my reference angle would be 40 degrees, and that matches what we logicked out. So that's how you would do that with both your formulas or thinking it through. All right, I do want to do these last two as well, just in case you need them. All right, 41 pi over 15. Okay, that sounds like a big one. It's okay. We are just going to follow our process. I'm going to put my initial side here on the positive x-axis. This is a positive angle, so it's going to rotate up counterclockwise from there. And I have to put my landmarks in. This is a positively rotating angle, so they'll go where they normally do. And I have to get a common denominator. What would the common denominator between my angle and all of my landmarks be? Yep, it would be 30. So I'm going to have to multiply this one by 2 over 2. I'm going to multiply this one by 15 over 15. I'm going to multiply this one by 30 over 30. I'll multiply this one by 15 over 15. And I'll multiply this one by 30 over 30 so that I can get to my common denominator of 30. So when I multiply this one out, I get that my original angle is 82 pi over 30. So I need to rotate to 82 pi over 30s. All right, so this one is 15 pi over 30. This one is 30 pi over 30. This is 45 pi over 30. And this one is 60 pi. That's a 6, sorry. 60 pi over 30. Okay, so we have our landmarks. So now let's rotate and see where we go. All right, we're going to start here and we're going to go up to 15. I'm going to 82, so I have to keep going. I'm going to get to 30. Got to keep going. 45. I got to keep going. 60. Ugh, I'm still not there. I'm going to have to keep going. But now I have to figure out what my kind of new landmarks would be, like what the coterminals are if we keep going around. So again, we're going to find the pattern. Up top was 15 over 30, 30 over 30, 45, 60. If I keep going, I'm adding 15 each time. So 60 plus another 15. This one's going to be 75 pi over 30. Again, if I add 15, this one's going to be 90 pi over 30. If I keep adding 15, this is going to be 105 pi over 30. And I only have to go to 82, so that's plenty. I can stop there. And then let's come back. Okay, let's see. So I went all the way around the circle and I was at 60 pi, and I have to go to 82 pi over 30. So let's keep going. We're up here at 75. And if I rotated all the way over here, I would be at 90, but that's too many. I only have to go to 82. So I'm going to go most of the way. Again, this doesn't have to be perfect. I'm looking for a ballpark between 75 and 90. I'm going to go closer to 90 than the 75. And so here we're going to be over here somewhere. Okay, there is my 15. There is my terminal side, and I'm here in quadrant 3. And so now I have to figure out where's my reference angle. It is right here. That's my theta ref between my terminal side and my x-axis, and we have to figure out how big that is. And again, it's the space between my terminal side, which here was 82 pi over 30, and my axis here, which the last reference point that we had was 90 pi over 30. So what's the space between 82 pi over 30 and 90 pi over 30? Yep, it is 8 pi over 30. Whew. All right, and if we wanted to do this with our formulas, then I would have to find, because this is it's a positively rotating angle, but it's not in one time, or it's not in one trip around the circle. It's not between 0 and 2 pi. So I would have to find a coterminal angle that is in one trip around the circle. So to find a coterminal angle that's less positive, I'm going to subtract 2 pi from this. That's going to give me the thing I'm going to use for theta in my formulas. So to subtract these, I have to get a common denominator. It's going to be 15. So 41 pi over 15 minus, if I multiply this guy by 15 over 15, I'm going to get 30 pi over 15. And when I subtract those, I get 11 pi over 15. Okay, so that's what I'm going to use for theta. And according to my formulas, this is in quadrant 2, right? My terminal side is here in quadrant 2. So in my formulas, it said that to find my theta ref, I'm going to do pi minus my theta. And here the theta value that I'm using is this 11 pi over 15. And I'm going to do pi minus 11 pi over 15. Again, got to get a common denominator. This is going to be a theme. You're going to do this a lot. 15 pi over 15 minus 11 pi over 15. That is 4 pi over 15. That's my reference angle. Does that match what I got before? I got 8 pi over 30. It does. I just didn't simplify my reference angle over here. 8 pi over 30, I can take a 2 at a top and bottom. That does, in fact, simplify to 14 pi over 15, or sorry, 4 pi over 15. It's the same either way. My brain just didn't see the simplification at first. And again, you can do it either way. Okay. Again, I'm going to do one last one. You might not need it at this point, but I want you to have it in case you need it. Okay, 580 degrees. Positively rotating angle. So we're going to start at my positive x-axis and rotate up counterclockwise. And we're in degrees. So this is 90, 180, 270, and this is 360. And again, we're going to rotate. It's a little bit easier to do this in degrees, right? So 580, I'm going to start here. I'm going to go all the way around to 360, and I'm going to need to keep going. So we're going to have to keep adding 90 degrees as we go. So 360 plus 90, this would be 450 degrees. And if I do 450 plus 90, this would be 540 degrees. I would still have to go a little further. So if I add 90 to 540 degrees, I would get, go brain go, 630 degrees. And that's far enough, right? So I'm going to go all the way up here to 450. I'm going to come over here to 540, and I still have a little bit further to go. I'm going to go 40 degrees, which is a little bit less than halfway here. There is my terminal side. That is 580 degrees. So that's how we graph that in standard position. And my reference angle is here, this little guy between the terminal side and the x-axis. And again, that's space. How much space is between my axis, 540 degrees, and my angle, 580 degrees? Yep, it's 40 degrees. And if you wanted to use our formulas from class, this is bigger than 360 degrees, so I can't use that in my formulas. I would have to find a theta value that's coterminal with that, but between 0 and 360. So I would have to take 580 and subtract 360 to get a coterminal angle that's less positive. And when I subtract those, I would get 220 degrees. That's between 0 and 360 degrees, so I'm good there. And then this is in quadrant 3. Go. And in quadrant 3, my formulas say that my reference angle should be theta minus 180 degrees. And so I'm going to take the theta here, which is my coterminal angle that's positively rotating in one rotation of the circle. That's 220 degrees minus 180 degrees. That gives me the same 40-degree reference angle that we got by logicking it out. Okay, so hopefully that helps with reference angles. Again, this can be kind of a tricky thing, but I think that graphing it in standard position, especially if you're visual, is going to help you a ton. And since this asked us to graph it, that makes it really easy. If you are just asked for the reference angle and you're not asked to graph it, you can use the formula method and not graph it. But I'm going to be honest with you, if your brain is very visual, I would graph it in standard position anyway to find your reference angle. It's going to make sure that you don't mess up your subtraction and that you get everything right. So I hope that helps. I hope you have a lovely weekend and happy reference angling. I will see you next time.